Root locus means locus of roots, locus of roots of closed loop system as k varies from 0 to infinity, as k varies from 0 to infinity. That is called the locus of roots. Up to second order, up to second order, we can easily find the roots and we can draw. But that too, we have to find the infinite number of roots. Then only we can draw. So some techniques are there, shortcut methods are there to draw the root locus without finding roots. There are some 8 set of rules. By using that, we can find the root locus. Let us see all those roots, all those rules. Set of rules. Before that, we have to find that closed loop transfer function. What is that? G of s upon 1 plus g of s h of s. So what is root locus? Roots of this denominator as k varies from 0 to infinity. That is called the characteristic equation. 1 plus g of s h of s equal to 0. That is the characteristic equation. The roots of this characteristic equation as k varies from 0 to infinity are called root locus. So this can also be written as g of s h of s can be written as 1 plus p of s equal to 0, or p of s equal to minus 1. P of s is g of s h of s, loop transfer function. Or we can say that modulus of p of s equal to 1 and angle of p of s. So we can separate this minus 1 in two parts. One is magnitude, another one is angle. Minus 1 means 180 degree. Therefore, angle of p of s equal to 180 degree. Normally we won't say 180 degree. Odd multiple of 180 degree. Odd multiple of 180 degree. That's why we can say that 2q plus 1 multiplied by 180 degree. Plus 180 minus 180 both are same. That's why we can say that plus or minus 2q plus 1 multiplied by 180 degree. So this minus 1 can be separated into two equations. One is called modulus of p of s equal to 1, or modulus of g of s h of s equal to 1. That is magnitude criterion. That is called magnitude criterion. Another one is called angle of g of s h of s equal to 180 degree. That is odd multiple of 180 degree. 2q plus 1, where q equal to 0, 1, 2, 3, etc. So this can be said as plus or minus 2q plus 1, 180 degree, angle of q of s. As k varied from 0 to infinity, always this condition will be satisfied for at least 1k. First condition always will be satisfied. If you substitute some value of k, as it varies from 0 to infinity, for any one of value, this condition will be automatically satisfied. That's why we can ignore this condition, because always it is satisfied for one value of k or another value of k. Therefore, any point that satisfies this condition is a roots of denominator polynomial. Any point that satisfies, suppose I am having a point s equal to p1. If you substitute p1 is a pole, if you substitute in this angle criterion, if it gives odd multiple of 180 degree, then point p1 is on the root locus. Similarly, we can check for p2, p3, etc. Like that, we can check any point. If it satisfies this, this will automatically be satisfied, because k varies from 0 to infinity. For one value of k or another value of k, this point will be satisfied. So we have to draw the root locus for second condition only, second equation only. So this second criterion is called angle criterion. Angle criterion. Suppose I am having some poles. Here one pole, another pole here, another pole here. 1, 0 is here. So what is the angle of, suppose I want to check whether this point P1 is on the root locus or not. For that, what I have to do is, I have to find the angle criterion, angle of G of S, H of S. What is that angle of P of S, H of S? Line connecting this pole and P1. What is the angle? Theta 1. What is the angle of this P1, this second pole? First pole, second pole. What is the angle? Let it be theta 2. What is the angle? Theta 3. What is the angle of with 0? Theta 4. If you add theta 1, theta 2, theta 3 and theta 4, if the angle, total angle is odd multiple of 180, means that point will be on the root locus. So we have to add minus theta 1 because pole is in the denominator. Pole is in the denominator. If you write G of S equal to S plus 1 upon S plus 2, S plus 3 means these are all in the denominator. If you find an angle for this, it will be negative. If you angle for 0, it will be positive. Therefore, theta 1 is negative because pole. Theta 2 is negative because pole. Theta 3 also negative because pole. Theta 4 is for 0, that's why positive. If you add theta 1, theta 2, theta 3, theta 4, if it is equal to odd multiple of 180 degree, then this point P1 is on the root locus. It's not possible to find this way. We have to check every point whether it is on the root locus or not. If you check like that, it's not possible to check. So there are set of rules which satisfies the second condition. 8 rules are there. That rules we will see. By using that, we can find the root locus. The first rule is root locus is symmetrical about real axis, because if the roots are on the real axis, suppose I am having some 3 poles on the real axis, 1 pole, 2 poles on the complex, then it will be like this. Another 0 is there, that is also on the real axis. 1 more 0, 2 more zeros are there, that is complex, that's why it will be like this. If you see, when k equal to 0, only open loop poles are there. Already we know that k n of s upon k multiplied by numerator of s plus denominator of s. This is closed loop transfer function T of s. If you put k equal to 0 in the denominator, only denominator of s, only there. That is open loop transfer function. When k equal to 0, closed loop transfer function becomes open loop transfer function. Closed loop transfer function becomes open loop transfer function when k equal to 0. Therefore, the poles and zeros are for open loop only. So if you draw the open loop poles, it will be like this. So these are all on the root locus, because when k equal to 0, it starts here, it starts here, it starts here, it starts here. If you see that above real axis, the below real axis, if you see, it is mirror image of whatever in the top part. So this is mirror image of top part, or the top part is mirror image of bottom part. It will be like that. Therefore, we can say that this root locus is symmetrical about real axis. How many branches will be there? Here, when k equal to 0, here the P1 pole starts here. When k equal to 0, P2 pole starts here. When k equal to 0, P3 pole starts here. When k equal to 0, P3 starts here. When k equal to 0, P4, P5 starts here. If you increase k, this pole will move. This pole will move. This pole also will move. This pole also will move. This also will move. This also will move. This also will move. So it is moving. So the number of branches, number of root locus branches equal to number of open loop poles. So here, how many open loop poles? 5 open loop poles. Therefore, 5 root locus branches are there. Root locus branches are there. Second condition is the root locus are symmetrical about real axis. Symmetrical about real axis. So that is the first condition. First rule. All, how many root locus branches? Number of open loop holes. Number of open loop holes. That is first rule. Second rule, all branches of root locus starts at open loop holes. All root locus branches starts at open loop hole. That we will see now. T of S equal to what? T of S equal to K multiplied by S power M plus A S power M, A1 S power M, A2 S power M minus 1 plus etc. plus A0. Numerator polynomial of degree M. Denominator polynomial will be B1 S power N plus B2 S power AM M minus 1, AM minus 1, let us call like that. Bn minus 1, etc. plus etc. So B0, up to B0 it will come. So what is the order of the system? Order is N. How many poles for this? N number of poles. How many root locus branches? N number of root locus branches. But where it will start when k equal to 0, that we have to say. For that, we can say that this is G of S. Let us call G of S. Factorize this. How many poles you will get? Z1, S plus Z2, etc. S plus Zm. Because M, degree of numerator is M. Degree of denominator is N. Therefore, S plus P1, S plus P2, etc. S plus Pn. N number of poles. So you'll get like this. The closed loop transfer function can be factorized like this. It can be written as K multiplied by product of J equal to or I equal to 1 to M product of S plus Zi. Like that. This Z1, Z2, Zm, the zeros can be like this product of. The denominator can be written as J equal to 1 to N S plus Pj. Like that we can write. We know that for a unity feedback system H of S equal to 1. Therefore, this 1 plus G of S H of S can be written as sum of numerator polynomial plus denominator polynomial. That characteristic polynomial is 1 plus G of S H of S. That is K. That is the product of I equal to 1 to M S plus Zi upon product of J equal to 1 to N S plus Pi equal to 0. This is the characteristic polynomial. This is the characteristic polynomial. Or we can say that product of J equal to 1 to N S plus Pi plus K times product of I equal to 1 to M S plus Zi. This is J, no? This is J. Equal to 0. If you put K equal to 0, this part becomes 0. This part becomes 0. When K equal to 0, the characteristic polynomial becomes this denominator part only. Denominator part only. Therefore, root locus branches starts at open loop holes when K equal to 0. When K equal to 0. This can also be written as what we got finally, product of J equal to 1 to N S plus Pj plus K times product of I equal to 1 to M S plus Zi equal to 0. If you divide on both sides by K, what you will get? 1 by K product of J equal to 1 to N S plus Pj plus this becomes 1. Therefore, product of I equal to 1 to m s plus zi equal to 0, dividing on both sides by k. If k tends to infinity, what will happen? K tends to infinity, this part becomes 0. This part becomes 0. This part becomes 0. This part alone is there. Therefore, when k equal to 0, it ends at 0. It ends at 0. We can say that the root locus branches are starts at pi's, pj's, starts at pj's and ends at zi's. Like that we can say, because when k equal to infinity, this part becomes 0, this part alone is there. Therefore, root locus branches will end at open loop zeros. Open loop zeros starts at open loop poles, that we know. But we know that m is always less than n. N is degree of denominator polynomial, m is degree of numerator polynomial. Therefore, the remaining, how many root locus branch will not end at 0? N minus m branches. Only m branches will end at 0. N minus m branches will, where to end? Where it will end? Where it will end? N minus m branches. Because out of n branches starts at open loop poles. How many poles will be there? Open loop poles, n poles will be there. It starts at n poles, end at m zeros. The remaining pole root locus branches are n minus m branches. Where it will end? It will end at infinity. It will end at infinity. So n minus m branches, n minus m branches, n minus m branches will end at infinity. Will end at infinity. For that, what we can do is, what is the characteristic polynomial? 1 plus product of j equal to 1 to m s plus zj. I put I earlier, so now also I put I. Divided by product of j equal to 1 to n s plus pj equal to 0. Or I can say that product of I equal to 1 to m s plus zi upon product of j equal to 1 to n s plus pj equal to minus 1. Already here k is there, in the numerator k is there. If you bring that k in the right hand side, you will get 1 by k. When k tends to infinity, it becomes 0. Here, the numerator has only m poles, number of terms. This number of terms equal to m. Here, this number of terms equal to n. We know that m is less than n. Therefore, as a limiting case, to this becomes 0, this s should be tends to infinity. This s tends to infinity e power j theta. If s tends to infinity, then only the left hand side becomes 0. Already, as k tends to infinity, right hand side is 0. When left hand side will be 0? As s tends to infinity. Therefore, the remaining poles n minus m branches will end at infinity. N minus m branches will end at infinity. So that is second rule. What is the second rule says? Second rule says all branches of root locus start at open loop poles when k equal to 0. Suppose I am having an open loop transfer function. G of s equal to k s plus 1 upon s plus 2, s plus 3, s plus 4. This is open loop transfer function. When k equal to 0, it will start at open loop pole. Open loop pole means where it will start. Where are the poles? One pole is at minus 2, another pole is at minus 3, another pole is at minus 4. Here and all, the root locus branch will start. 1 0 is there. Where? Here at minus 1, 1 0 is there. One of the branches will end here. So it may be like this. This 2 starts here and end at -1. One branch will end at -1. Remaining 3 branches will go to infinity. How many? How many? Totally how many branches? Only 3 branches. One end at -1. The remaining 2 will go to infinity. So I know this by rule. I know this root locus. They will meet each other at some point. Then it will go up. Another one will go down. Huh? Third rule says a point on the real axis. A point on the real axis lies on the root locus. Lies on the root locus. What is point on the real axis? Point on the real axis. This is S plane. We will draw the root locus on S plane. This is real axis. This is imaginary axis. Any point on the real axis. Suppose I am selecting a point S0. A point. This is a point on the real axis. On the root locus, if the sum of poles and zeros on the real axis to the right of the point is odd number, we will take the same example. What is that? We took S plus 1 upon S plus 2, S plus 3, S plus 4. So here minus, this is 0. This is 0. The remaining, this is minus 2, this is minus 3, this is minus 4. This is minus 1. 1, 0 is at minus 1. Other 3 poles are at minus 2, minus 3, minus 4. So, one point I am selecting here. Whether this point is on the root locus or not, how to check? We know that line joining from all poles to that point. Already we have seen Evans condition. Suppose this point, whether this point is on the root locus or not, how we will find? We will draw a line from that point to all poles and zeros. We will measure the angles theta 1, theta 2, theta 3. If we add all the angles, it should be odd multiple of 180 degree. So this is the point. So draw a line from all poles and zeros. From minus 1 to S0, if you draw a line, the angle of this line is 180 degree. Minus 180 degree. If you draw a line from minus 2 to this point S0, the angle is 0 degree. Angle is 0 degree. Towards the right we are. Any point is there. If you draw a line like this, what is the angle? 0. A point is there. If you draw a line like this, what is the angle? 180 degree. Therefore, this is 0 degree. What is the line joining minus 3 and the S0? That is also 0 degree. What is the line joining minus 4 and S0? That is also 0 degree. Add all the angles. If it is S0, from S0 if you add S0 to 0 means positive. Plus 1, plus, because it is in the numerator. Plus 180, plus 180, angle is minus 180, but plus minus 180, plus 0, plus 0, plus 0 equal to plus 180 degree. Sorry, minus 180 degree you are getting. Because the angle is minus 180 degree. If you add all the angles, you will get minus 180 degree. It satisfies the condition. Therefore, S0 is on the root locus. If you select any point between minus 1 and minus 2, angle will be 180 degree. Am I correct or not? Angle will be 180 degree. Therefore, all points between minus 2 and 1 are root locus. I have drawn the root locus. Root locus starts at minus 2 because minus 2 is open loop pole. Starts at minus 2, ends at minus 1, open loop 0. So, any point between minus 2 and minus 1 is root locus. Therefore, one branch completed. One branch completed. It starts at minus 2, ends at minus 1. Similarly, we have to check here. I am selecting S1, another point between minus 2 and minus 3. Whether it is on the root locus or not, I have to check. Draw angle from minus 1 to S1, 180 degree, minus 180 degree. From minus 2 to S1, you will get another minus 180 degree. Another minus 180 degree. From minus 3 to S1, you will get 0. Minus 4 to S1, you will get 0. So now we have to add. This is for pole. This is for 0. That's why we have to put plus, we have to add. But we have to subtract this. We have to subtract this. Why? It is angle for pole, denominator. That's why minus. Minus of minus, this becomes plus. This is minus. Therefore, net angle becomes 0, not 180 degree. Not 180 degree. That's why any point between minus 2 and minus 3 is not on the root locus. Any point between minus 2 and minus 3 is not on the root locus. Suppose let us select one more point, S2. S2 is a point, test point. I am selecting test point to check whether it is on the root locus or not. Between minus 3 and minus 4. How many angles? If you draw a line from minus 1 to S2, minus 180 degree. If you draw a line from minus 2 to S2, another 180 degree. If you draw a line from minus 3 to S2, you will get another 180 degree. Draw a line from minus 4 to S2, you will get 0. What are all for poles? This is for poles. This is also for pole. This is for 0. Therefore, minus. This is plus, minus, minus. Minus or minus, this becomes plus. This also becomes plus. These two getting cancelled. This is minus 180. This is plus 180. These two getting cancelled. What is the remaining angle? Plus 180 degree. Plus 180 degree. Therefore, it is odd multiple of 180 degree. Odd multiple of 180 degree. Therefore, any point between minus 3 and minus 4 is on the root locus. Therefore, 4 starts. Always we said 4 is open loop pole is starting point. Therefore, minus 4 also starting point. Minus 3 also starting point. Therefore, if minus from minus 4 starting point, minus 3 also starting point, that's why they will come and meet at one point. They will come and meet at one point. Let us select one more test point after minus 4. That is S3. After minus 4, all poles and zeros on the right hand side. All the poles and zeros are on the right hand side. What is the angle from minus 4? Minus 180 degree. What is the angle from minus 3? Minus 180 degree. What is the angle from minus 2? Minus 180 degree. What is the angle from minus 1? Minus 180 degree. These are all in the denominator. First 3 are in the denominator. That's why minus. It becomes plus, plus, plus. This is minus. These two getting cancelled. What is the remaining? 180 plus 180. 360. It is not odd multiple of 180 degree. It is not odd multiple of 180 degree. It is even multiple of 180. 360 degree is 0. 360 degree is 0. Therefore, it is not odd multiple of 180 degree. Therefore, any point from minus 4 to infinity, minus infinity, it is not on the root locus. It is not on the root locus. That's all. So, these two branches approach each other and break away at this point. One goes to plus 90, another goes to minus 90. That we will see in another rule. So, whether it is on the root locus or not, we check. Real axis, whether it is on the root locus or not, we check. That is third rule. Fourth rule, by using 3 rules, we can draw some root locus. Let us draw the root locus for this. Draw the root locus for the unity feedback system with open loop transfer function. Zeros are what? How many branches? How many poles? How many poles? N equal to 3. How many zeros? 2. How many zeros are? Z equal to minus 1 comma minus 3. Am I correct or not? Poles are equal to what? 0 comma minus 2 comma minus 4. Am I correct or not? These are all poles. Therefore, n equal to 3, m equal to 2. How many root locus branches are there? Number of root locus branches equal to number of open loop poles. Therefore, number of branches equal to 3. How many will end at 0? 2 branches. 2 branches will end at 0 because 2 zeros are there. 2 branches end at zeros because 2 zeros are there. How many will go to infinity? Only one will go to infinity. Only one, because one goes to infinity because n minus m equal to 3 minus 2 equal to 1. N minus m branches will end at infinity. Now we have to draw the root locus. We have to draw the root locus. So we have to take S plane. What is the first rule says? Number of root locus branches equal to number of poles. Root locus branches are symmetrical about real axis. This is the first condition. What is the second condition? Root locus branches starts at open loop 0. Here 1 0. Minus 2 another 0. Minus 4 another see, one pole is at 0, another pole is at minus 2, another pole is at minus 4. Where and all 0? 0 is at minus 1, minus 1. Another 0 is at minus 3. That's all. Now we have to apply third rule. Third rule says what? Open loop pole, second rule says root locus branches starts at open loop poles. So this is one starting point. This is another starting point. This minus 4 is another starting point. Ends at where it will end. One root locus branch will end at minus 1. Another will end at minus 3. Third will end at infinity. Third will end at infinity. 3 root locus branches are there, out of which one will end at infinity. We have to check, take the test point and check whether it is on the root locus or not. If we select between 0 and minus 1, any point between 0 and minus 1, if I select one point to its right, how many poles and zeros? Odd number of poles and zeros. Therefore, it is part of root locus. By using third rule, we can say that if you select any point between minus 1, 0, it is part of root locus. Therefore, this root locus branch start at 0, end at minus 1. One branch is over. Between minus 1 and minus 2, no, it is not part of root locus. Why? Any test point if we select, therefore I am selecting test point between minus 1 and minus 2. I am selecting test point between, S1 is this test point, between minus 1 and minus 2. To its right, how many poles and zeros? Even number of poles and zeros. Even number of poles and zeros. Therefore, it is not part of root locus. Real axis is not part of root locus. If we select between minus 3 and minus 4, to its right, how many poles and zeros? Odd number of poles and zeros. So you will get 180 degree. Therefore, this any point, any test point between minus 3 and minus 2 is part of root locus. Therefore, it starts at minus 2, end at minus 3. Starts at minus 2, end at minus 3. That is also root locus. Second branch also over. If we select any point between minus 3 and minus 4, it is not part of root locus. To its right, how many poles and zeros? Even number of poles and zeros. That's why it is not part of root locus. After 4, if you select, after minus 4, if you select any point, to its right, odd number of poles and zeros. Therefore, from minus 4 up to infinity, it is part of root locus. So, all the 3 root locus branches we have drawn. Completed. So, root locus sum will be asked in 8 marks as well as 2 marks. This sum is 2 marks. You can draw the rough root locus branch. Rough root locus branch. So, one root locus branch starts at minus 0, another starts at minus 2, third starts at minus 4. The root locus starts at minus 0, ends at minus 1. Minus 2 ends at minus 3. Minus 4 ends at infinity. That's all. That's all. Fourth rule. Fourth rule. We have seen that n minus m branches will end at infinity because number of poles n number of poles, m number of zeros. N poles, the root locus branch will at n points. So number of branches equal to n. Only m poles will end at 0. The remaining n minus m branches will end at infinity. End at infinity. In the previous case, this root locus branch end at infinity at an angle 180 degree. It goes to infinity at an angle 180 degree. So, like that, here we have to find an angle for n minus m branches Suppose, let us assume that n minus m branches are end at infinity. Some root locus branches end at infinity. Here one pole, here one pole, here one pole, here one pole. Here one end, one ends. Here one ends. This is at infinity. S1 is at infinity. S2 is also at infinity. The root locus branches starts here. Root locus branches starts here, approach each other, and it will go to S2, infinity. So, if you draw a line parallel to this line, that is called asymptote, because this parallel line will meet the graph at infinity. That is why it is called infinity. Infinity means, asymptote means tangent at infinity. Tangent, two parallel lines mathematically where they will meet. Two parallel lines where they will meet at infinity. Mathematically they will meet at infinity. Therefore, a parallel line is called asymptote. Asymptote means tangent at infinity. Tangent means what? They are touching each other. Where they are touching? At infinity. Therefore, if you draw a asymptote parallel to this graph, if you draw an asymptote, this is called asymptote. 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 This asymptote will meet the graph at infinity. Another goes to infinity at this angle. If you draw a line parallel to this, this is called another asymptote. This is called another asymptote. What is the angle of that asymptote? We can find the angle of asymptote. So, how many branches end at infinity? N minus m branches. N minus m branches end at infinity. N minus m branches end at infinity. What is the angle made by all these asymptotes? Let us assume that it is called phi a. What is the angle contributed by this S1 and S2? Phi a. Angle contributed by S1 and S2 are phi a. Because it is a point at infinity, if you draw a line from that point to each pole, the angle is phi a. The angle is phi a. That is called asymptote. That is called asymptote. What is the total angle made by all these points? N minus m multiplied by phi a. Am I correct or not? Each giving an angle of phi a, the total angle, how many points at infinity? N minus m points at infinity. So n minus m branches end at infinity. Therefore, angle made by all these points, I am having n minus m points, S1, S2, S3, etc. N minus m branches points at infinity. If you draw a line from that infinity to that pole, that angle is phi a. Therefore, total angle made by all these lines equal to n minus m multiplied by phi a. That must be equal to 2q plus 1 multiplied by 180. Am I correct or not? Because that is the criteria to satisfy whether that point is on the root locus or not. So if you add all these angles, you will get 2q plus 1. Therefore, that angle phi a equal to 2q plus 1 multiplied by 180 divided by n minus m, plus or minus 2q plus 1, plus or minus we can add, plus or minus 2q plus 1 180 divided by n minus m. As q varies from 0, 1, 2, etc. One phi a you will get for 0, another phi a you will get for 1, another phi a you will get for 2. Like that, you will get n minus m angles. N minus m angles you will get. So, whether this point is on the root locus or not, for that what we have to do? From S1 to all poles we have to draw line. That is called asymptote. The angle made by S1 to all poles equal to phi a. How many lines we have drawn? N minus m lines we have drawn. Because the remaining are ended at 0. Only n minus m lines we have drawn. Therefore, total angle equal to n minus m multiplied by phi a. N minus m multiplied by phi a. Therefore, the angle of asymptote equal to plus or minus 2q plus 1 multiplied by 180 divided by n minus m. That is the formula to find the angle. These asymptotes are meeting at sigma a. This is one asymptote. This is another asymptote. This is third asymptote. This is fourth asymptote. This is fifth asymptote. All will meet at a point called sigma A. Sigma A. All will meet at a point called sigma A. That sigma A equal to sum of real parts of poles minus sum of real parts of zeros divided by n minus m. That is equal to sum of real parts of poles minus sum of real parts of zeros divided by n minus m. That is the formula. That is the formula. Sigma A equal to, what is numerator polynomial? K multiplied by product of I equal to 1 to m s plus z I divided by product of 1 plus characteristic polynomial j equal to 1 to n s plus p j equal to 0. Equal to 0, or we can write k multiplied by product of I equal to 1 to m s plus okay. This can also be, the numerator can also be written as s power m plus sum of I equal to 1 to m zi of s power m minus 1 plus etc. plus product of I equal to 1 to m s power, that is z all zi's. If you expand this, you will get the polynomial like this. What is this? The first term is s power m, second term is s power m minus 1, the last term is s power 0. The coefficient of second term is sum of all zeros. Sum of all zeros. The coefficient of last term, constant term, is product of all zeros. Similarly, denominator also we can write like that. S power n plus sum of poles s power n minus 1 plus etc. The last term is product of all poles. This way we can write. That is equal to minus 1. That is equal to minus 1. This can, if you divide the denominator by numerator, divide the denominator polynomial by numerator polynomial, divide the numerator and denominator by numerator polynomial. What you will get? Numerator becomes 1. Denominator becomes s power n minus m plus sigma I equal to 1 to n minus pi's minus sigma j equal to 1 to m, j equal to 1 to m zj s power n minus m minus 1 plus etc. plus the product of these two terms you will get. Let it be. For large value of s, we can approximate the denominator to only two terms. Only two terms. For large values of s, we can approximate this to only first two terms. Let it be 1. Let it be 1. Let us take one more system, g of s, that is equal, that has repeated poles at sigma a. How many repeated poles? n minus m repeated poles it has. N minus m repeated poles at sigma A. If we expand this, in binomial expansion, you will get s power n minus m plus sigma A s power n minus m minus 1 plus etc. If we compare these two, the second term is equal to here one more coefficient, that is n minus m. Here coefficient is n minus m sigma A s power n minus m minus 1. N minus m. So this is binomial expansion of this to the power n minus m. So if you compare these two, what you will get is n minus m multiplied by sigma A equal to sum of I equal to 1 to n poles minus sum of j equal to 1 to m, sum of zeros, you will get. Therefore, sigma A equal to sum of real parts of sum of poles minus sum of zeros divided by n minus m. But we know that the complex conjugate will be plus minus 1 plus 1 minus. If you add, complex part will be getting cancelled. Therefore, instead of writing like this, we can write sum of I equal to 1 to n, real part of poles minus sum of real parts of zeros, divided by n minus m. Therefore, sigma A equal to the point at which the asymptotes are meeting is sigma A. How we are comparing these two? Here, how many repeated poles? N minus m repeated poles at sigma A. No zeros. N minus m root locus branches will end at infinity, the second case. So, in the first case, m root locus branches already end at 0. The remaining n minus m are there. That's why these two are identical. That's why we can compare these two. If we compare these two, we are getting this relation. N minus m sigma A equal to sum of poles minus sum of zeros. Therefore, sigma A equal to sum of real parts of poles minus sum of real parts of zeros divided by n minus m. So now, how many rules we have seen? 5 rules. Let us draw root locus for this. By ds. What is breakaway point? First, let us see what is breakaway point. Sometimes here one pole, another pole here, both are starting points. If we select any point after this, even number, that's why it is not any point after this, it is not part of root locus. But if we select any point between these two poles, it is part of root locus. Therefore, root locus coming from this pole in this way, from this pole this way, both are meeting at one point. Then they are breaking away, and this goes to infinity and this goes to infinity. A second order system. So this point is called breakaway point. This point is called breakaway point. How to find that breakaway point? They are approaching each other, but at what point they are breaking away? We do not know. That can be found by using dk by ds. What is the characteristic equation? 1 plus g of s h of s equal to 0. That is characteristic equation. G of s h of s can be written as 1 plus k times n of s upon d of s. We can write of s upon d of s. Suppose suppose this characteristic equation is equal to 1 plus g of s h of s equal to s plus say mn b s plus b to the power r multiplied by x of s. The polynomial, characteristic polynomial is written like that. It means what? What is the meaning of this? It has repeated poles. It has repeated poles at r points. It has r repeated poles. It has r repeated poles. The remaining polynomial is x of s. Remaining polynomial is x of s. Suppose if it is nth order degree, means the degree of x of s is n minus r. Because r is we have taken separately. It has repeated roots. What is the breakaway point? It has two roots at the same point. Two roots at the same point. It means repeated roots. Breakaway point means repeated roots. So the repeated roots at b repeated are repeated roots. How many? R repeated roots at b. R repeated roots at b. R repeated roots at b. This polynomial has, this characteristic polynomial has r repeated roots. Suppose I am differentiating this with respect to s. What you will get? D, let us call this as p of s. Characteristic polynomial can be called as p of s. dp of s upon ds equal to, if you differentiate this, what you will get? R multiplied by s plus b to the power r minus 1. If you differentiate this, you will get 1 plus multiplied by x of s. If you differentiate the characteristic polynomial, you are getting this. Is it true? Is it 0 for s equal to minus b? Where the repeated roots? The repeated roots are at minus b. Repeated roots are minus b. So characteristic polynomial must be 0 for minus b. If you substitute minus b there, because it has repeated roots at minus b, that's why it becomes 0. The characteristic polynomial becomes 0. The characteristic polynomial becomes 0. This becomes 0, equal to 0 at s equal to minus b. Because at minus b, it has r repeated roots. You check dp by ds. That is also equal to 0 if s equal to minus b. You check, if you substitute minus b, this becomes 0. This becomes 0. If you substitute s equal to minus b, this also becomes 0. So the entire equation becomes 0. So if characteristic polynomial is 0 for minus b, means its derivative also 0 for minus b. That's why we can find the derivative of the characteristic polynomial and equate to 0 to find the repeated roots. Let us differentiate this. What is the characteristic polynomial? This is the characteristic polynomial. If we differentiate that, what is dp of s? The characteristic polynomial by ds equal to, if we differentiate this, 1 becomes 0 plus, what is that? d of s square, d of s multiplied by k times n of s n dash of s minus k n of s d dash of s. Can I write like that? S equal to minus b. Or I can say that d of s k d of s n dash of s minus k can be taken outside. D of s minus n of s, n dash of s minus n dash of s. D of s, n dash of s. Okay. N of s multiplied by d dash of s equal to 0. Because denominator can be become 0. If you bring this to right hand side, it becomes 0. Therefore, numerator equal to 0. So, to find repeated roots, we have to find d of s multiplied by n dash of s minus n of s multiplied by d dash of s equal to 0. If you equate that, you will get repeated roots. To find repeated roots, what we have to do is, we have to find d of s multiplied by n dash of s minus n of s multiplied by d dash of s equal to 0. K is not equal to 0. Therefore, this is the condition. This is the condition to find repeated roots. Because repeated roots are roots of dp by ds. dp by ds. So, the same condition can be obtained by dk by ds also. What is k? 1 plus k n of s upon d of s equal to 0 means, what is k? K n of s by d of s equal to minus 1, or n of s by d of s equal to minus 1 by k. Or this implies k equal to minus d of s upon n of s. Am I correct or not? K can be found. Therefore, dk by ds equal to dk by ds equal to, what is dk by ds? dk by ds equal to dk by ds equal to n of s square n of s d dash of s, d dash of s is in the numerator, minus d of s n dash of s. One minus sign is there. That is equal to 0. Or we can say that n of s d of s, d dash of s plus d of s n dash of s equal to 0. Or you can write d of s n of s n dash of s plus minus n of s d dash of s equal to 0. We got the same. 1 and 2 are same. So even if you find dp by ds or dk by ds, both are same. Gives the same result. Therefore, to find the repeated roots, we can find dk by ds and equal to 0. Therefore, dk by ds equal to 0 will give repeated roots. So now we have 6 rules. This sum is sufficient to solve 6 rules. Another 2 rules we'll see later. So what is the root locus? For that we have to find the roots. N equal to what? N equal to 3. M equal to what? 1. So 3 root locus branches. 1 will end at 0. The remaining 2 will end at infinity. The remaining 2 will end at infinity. So 2 end at infinity. 2 end at infinity. 1 will end at 0. What are the poles? Poles are minus 2, minus 3, minus 4. Zeros are at minus 1. Now we have to draw the root locus. The graph sheet take only one column on the right hand side, because root locus normally won't be on the right hand side. If it is there, you take. Otherwise, you can shift the y-axis not in the middle, to the rightmost. Sigma j omega, S plane. So 0 is at minus 1, minus 1, 1, 0 is at minus 1. At minus 2, one pole is there. At minus 3, another pole. At minus 4, another pole. What is first rule says? How many root locus branches? 3 branches. 3 branches. Because 3 poles are there, open loop poles, therefore 3 branches. Second rule says, one root locus branch will end at 0, another 2 will end at infinity. Then third rule says, what is third rule? A point on the real axis. A point on the real axis, whether it is on the root locus or not. If you select any point between minus 1 and 0, is it on the root locus? Any point between 0 and minus 1. It is not on the root locus because 2 is right even number of poles and zeros. But if you select any point between minus 1 and any point between minus 1 and minus 2, it is part of root locus. Therefore, root locus starts at minus 2 and end at minus 1. Starts at minus 2, end at minus 1. Is there any root locus branch between minus 2 and minus 3? If you select a test point between minus 2 and minus 3, no, because 2 is right even number of poles and zeros. But if you select any point between minus 3 and minus 4, odd number of poles and zeros, therefore it is part of root locus. 4 also starting point, 3 also starting point. Between these two at one point, repeated roots are there. Repeated roots are there. Repeated roots are there. Now we have to find the repeated roots. Therefore, what is n of s? N of s equal to what? N of s equal to s plus 1. What is d of s? D of s equal to s plus 2 multiplied by s plus 3 multiplied by s plus 4. What is that? S square plus 5s plus 6 multiplied by s plus 4. That is s cube plus 5s square plus 6s plus 4s square plus 20s plus 24. That is equal to s cube plus 9s square plus 26s plus 24. That is denominator. That is denominator. How to find repeated roots? Formula is d of s n dash of s minus n of s d dash of s equal to 0. Or you can write n of s d dash of s minus d of s n dash of s. Both are sign. Only minus sign. The problem. That's why what is d of s? D of s is s cube plus 9s square plus 26s plus 24. Check for any numerical mistake. Multiplied by n dash of s. If you differentiate that, you will get 1 minus derivative of d of s. What you will get? 3s square plus 18s plus 26 multiplied by s plus 1 equal to 0. Find the polynomial and find the roots. Find the polynomial and find the roots. 3s cube plus 18s square plus 20 3s cube 18s square plus 26s plus 3s square plus 18s plus 24, sorry, 26. S equal to roots are S equal to minus 1.381 minus 3.61 minus 2.5. These are the three roots. Out of these three roots, which is the repeated roots? Out of three roots, how? At 1.381 minus 1.381 is here. Here. Whether it is repeated root? No. It starts at minus 2 and ends at minus 1. It is not repeated roots. Minus 2.5 is here. It is not part of root locus. Minus 2.5 is not part of root locus. Minus 1.3 is no repeated root. It is not repeated root. But minus 3.61 is here. Therefore, minus 3.61, that is minus 3.61 is repeated roots, and it is breaking away like this. Breaking away at minus 3.61. We found the breakaway points. We found the breakaway points. What is the angle of asymptote? How many asymptotes will be there? N minus m asymptotes will be there. Out of three root locus branches, one ended to 0, the remaining two goes to infinity, means only two asymptotes. What are the angles? Formula is phi a equal to plus or minus 2q plus 1 multiplied by 180 divided by 3 minus 1, that is equal to q equal to 0 comma 1, only two values. Q equal to 0 means what you will get? Divided by 2, 180 divided by 2, 90. One angle is 90, another one is 270. 270. So, angles are this. What is sigma A? Angle of asymptote sigma A equal to sum of real parts of poles minus sum of real parts of zeros divided by n minus m, that is 2. Real parts of poles minus 3 plus minus 2 plus minus 4 minus 9 minus 9 minus 9 minus of minus plus 1 minus 9, sum of real parts of poles equal to minus 9, sigma A equal to minus 9 minus of minus 1 divided by 2, that is equal to minus 4. So the asymptote is at minus 4. Asymptote is at minus 4. One asymptote goes upwards, another one goes downwards. Therefore, the root locus branch come closer to this minus 4 and goes to infinity like this. It goes to infinity like this. This is asymptote. This is asymptote. Asymptote. This is root locus. This is root locus. Root locus. It goes to infinity. Up to infinity it goes. This is go to j infinity. It goes up to j infinity. This goes to minus j infinity. Two asymptotes. One is at plus 90. Another one at minus 90. Or 270. That's all. So we used all the 6 rules and solved this sum. Already we have seen what is the angle of departure. Here it is required. Here, at what angle it is coming out of 2j, we have to find. At what angle it is coming out of minus 2j. At what angle it is coming out of minus 2j, we have to find. That can be found by the rule 7, angle of departure. The coming out of pole is called a departure. Arrival. If it is reaches 0, then it is called arrival, angle of arrival. Sometimes angle of arrival also required. For example, I am having two complex pole and complex 0. Here I have complex pole and a complex 0. Complex 0. These two are complex zeros. Two poles and two zeros. What will happen? This will come out and join here. This will come out and join here. At what angle it come out? We have to find. At what angle it come out? We have to find. At what angle it reaches? At what angle it reaches the 0? This is called angle of arrival. This is called angle of arrival. This is called angle of departure. Angle of departure. Angle of departure. We have to find both. We have to find both. Now let us find the angle of departure. Suppose I am having a how many poles are there? 4 poles are there. 1 0 is there. 2 more poles are there. 2 more poles are there. 7 poles, 6 poles. 6 poles and 1 0. For that I have to draw the root locus. All the open loop poles are starting points. These are all starting points. This is pole 1, pole 2, pole 3, pole 4, pole 5 and pole 6. All are starting points. What is the end point? This Z1 is the end point. Only one end point. So out of 6 starting points, only one end at 0. The remaining 5 will go to infinity. Remaining 5 will go to infinity. Remaining 5 will go to infinity. But here, 2 complex poles are there at P5 and P6. There will be angle of departure. Angle of complex pole is there means angle of departure. From P5, whether the pole is coming out from P5, it is coming out like this or like this or like this. We do not know. At what angle it is coming out, we do not know. From P5. From P5, we have to find. How to find? How to find? Suppose, let us assume that this is, I am selecting closest point, one point, S1. I am selecting S0. Very close to P5. Here I am drawing little bit away, but I am selecting very close to P5. If I join, suppose S0 is on the root locus, means the line of joining S0 and P5 is the angle of departure. Am I correct or not? Because S0 is very close to S5. If I draw the, line joining S0 and P5 is the angle of departure. Am I correct or not? Because S0 is very close and S0 is on the root locus. S0 is on the root locus. So if S0 is on the root locus, means we have to find the angles with P1, that is theta 1, with P2, theta 2, with P3, theta 3, with P4, theta 4, with P6, theta 6, theta 6. This angle is theta 5. Am I correct or not? The angle of departure from P5 is theta 6. We have to find theta 6. We do not know what angle it is coming out. Theta 6 we have to find. If you join the line P5 and S0, that is the angle. It is coming like this, means the angle is, this is the angle. That is theta 5. Theta 5 we have to find. We know that S0 is on the root locus. Therefore, if you add all these angles, it must be equal to what? 180. 2q plus 1 multiplied by 180. Therefore, I am writing theta 1 plus theta 2. I would put minus because theta 1. And for Z1 also we have an angle. That is theta 7, let us call. Or theta Z, let us call. One more angle is theta Z. So, minus theta 1, minus theta 2. Why I put minus theta? Because for poles, theta 1, theta 2, theta 3 are for poles. Minus theta 3, minus theta 4, minus theta 5, minus theta 6 and minus theta Z equal to plus or minus 2q plus 1 multiplied by 180. Am I correct or not? If you add all angles, I would put plus because it is for numerator. Theta 1 may be minus 70. Theta 1 may be minus 70. But why we are putting this minus sign? Because for denominator. minus theta 1. Theta 1 may be minus 70. So minus or minus it becomes plus. Why I put minus 1? Because these angles for denominator polynomial. Theta 1, theta 2, theta 3 up to theta 6 it is for denominator polynomial. That's why minus. Theta z is for numerator. That's why plus. If you add all this, that must be equal to 2q plus 1 plus 180 plus 1 multiplied by 180. Let us, what is required? Theta 5 is required. Theta 5 equal to minus theta 5 equal to plus or minus 2q plus 1 multiplied by 180 plus theta 1 plus minus theta 1 or minus of minus theta 1 minus theta 2 minus theta 3 minus theta 4 minus theta 6 minus plus theta z. Except theta 5, I brought all to the right hand side because I have to find theta 5. I have to find theta 5. So if I know theta 1, theta 2, theta 3, theta 4, theta 6 and theta z, theta z, then I can find theta 5. Am I correct or not? If I know all these angles, theta 1, theta 2, theta 3, what is theta 1? Line joining S0 and P1. What is theta 2? Line joining S0 and P2. What is theta 3? Line joining S0 and P3. Theta 4, line joining S0 and P4. What is theta 6? Line joining S0 and P6. If I know these angles, I can find theta 5. But I do not know these angles. But I know that S0 and P5 are very, very close. Very close. Very, very close. That's why if I find the angle from P5 to P1 and the angle from S0 to P1 are same. Can I say like that? Theta 1 is equal to, listen here, theta 1 is equal to line angle made by line joining P5 and P1 or line joining S0 and P1. Can I say like that? Because S0 and P5 are very close to each other. S0 and P5 are very close to each other. That's why angle made by P1 and P5 and angle made by P1 and S0 are same. That's why I can say that theta 1, theta 2, theta 3, theta 4, theta 6 and theta z are angle made by line joining P5 to all other poles and zeros. Lines joining P5 and all other poles and zeros. That is called the net angle contributed by line joining P5 and all other poles and zeros. What is the angle in question? Angle of departure from P5. Angle of departure from P5. Therefore, I am finding net angle by joining P5 and all other poles and zeros. That is P5 and P1, P5 and P2, P5 and P3, P5 and P4, P5 and P6, P5 and Z1 are connected. We are finding an angle that assuming that that is equal to line joining S0 and all the poles. So, therefore, plus or minus 2q plus 1 multiplied by 180, this minus 5 net. I am calling that angle equal to phi net. What is phi net? Phi net is angle made by lines joining P5 and all other poles and zeros. Angles made by lines joining P5 and all other poles and zeros. That's all. So I can find theta phi simply by finding phi net. What is phi net? Phi net is angle contributed by lines joining P5 and all other poles and zeros. That's all. That's all. Similarly, you can find theta 6. Normally, it is mirror image. Already we have seen. Rule number says 1. It is symmetrical about. Therefore, for P5, it is coming out at an angle minus 60 means for P6 it will be plus 60. Suppose from P5, this is P5, this is P6. Suppose this is coming out at minus 60 means it should be plus 60. Why we have to find P6? No need. If it is minus 60 means for this plus 60. So it is coming out at an angle like this. Here it is coming out at this angle. So we have to find that, we can find that angle minus theta phi equal to plus or minus, or you can write theta phi equal to plus or minus 2q plus 1 multiplied by 180 plus phi net. So theta phi equal to plus or minus 2q plus 1 multiplied by 180 plus phi net. So to how to find theta 6? You would put, instead of plus you would put minus, that's all. Instead of plus you would put minus, or after finding that, negate that, you will get the angle, because it is symmetrical about real axis. It is symmetrical about real axis, that's all. That is the angle of departure. The same way you can find the angle of arrival. For that angle, suppose angle of arrival means instead of plus it will be minus. Instead of plus it will be phi net will be here added, there you have to subtract, that's all. What is phi net? Phi net is line joining the pole or zero under question. Pole or zero under question to all other poles and zeros. Lines, angle made by lines joining the pole under question to all other poles and zeros. Do you understand that? What is theta phi? Angle of departure from P phi. So this is the formula. Phi P, I am calling it as phi 5 because for fifth pole we found, generally we can call it as phi P, or you can call it as phi Z. If it is from angle of arrival means phi Z. For phi Z it is minus. For pole it is plus. That's all. That is the only difference. Sketch the root locus for a system. I will give idea, you solve yourself. Sketch the root locus for the system with open loop transfer function. What are the poles? Poles equal to S1 comma S2 equal to minus B plus or minus square root of B square 16 minus 4 AC 52. Equal to how much? What are the poles and zeros? Minus 2, 3J. Okay, J3. Okay. Minus 2 plus or minus J3. The poles are at. So one pole at minus 2. This is, minus 1, minus 2, minus 3. Here J plus J plus 2J plus 3J minus J minus 2J minus 3J. 0 is at Z equal to minus 1. 0 is at minus 1. Poles are at, one pole is here, another pole is here. Therefore, angle of departure you have to find. How to find angle of departure? Line joining this and this you have to find. What is this angle? It is obvious. 90 degree. This is 90 degree. What is this angle? This angle. Here what is this? What is this? Minus 2 plus or minus plus J3. Am I correct? Minus 2 plus J3. Use calci. You follow what I am saying. Minus 2 plus J3 minus 1 equal to what? Minus of minus 1. Minus of minus 1 equal to what? Subtract from this P2. This is P1. This is P1. Subtract this P2 minus Z1 equal to what? Subtract. You will get minus 2 plus 1 plus J3. That is minus 1 plus J3. Am I correct or not? What is the distance between these two? You have to subtract from this point from this point. This is minus 1, this is minus 2 plus J3. If you subtract that, what you will get? Minus 1 plus J3. Am I correct or not? Call the function polar to rectangle. Call P -1, 3. Enter -1, 3. Press equal to polar to rectangle function. 3.16 magnitude. Find the angle. 108.4. You can directly find that angle 108.4 degree. I understand this. Test point minus other pole. Test point minus other pole. Then enter in polar to rectangular coordinate. You will get the angle immediately. You will get the angle immediately. You can enter 108.4. This is 90. So this is minus 108 minus 90. This is plus 1 because from 0. That's why plus. This is minus. What is the net angle? Phi net equal to minus 90 plus 108. This is plus 90 only. Why I put minus 90? Because denominator. So equal to what? 108.4 minus 90 equal to what? 18.4. Therefore, angle of departure from P2 equal to plus or minus 2q plus 1 multiplied by 180 plus 18.4 degree. Already we have seen 7 construction rules. Today, let us see the 8th and 9th rule. Then we will see some problems on root locus construction. 8th rule says the intersection of a root locus with imaginary axis can be determined using Routh criterion. For example, I am having a third order system. We know that one root locus branch go to infinity like this. Another two will go to infinity, one at an angle 60 degree like this. Another one will go to infinity minus 60 degree like this. But the point of intersection at the imaginary axis we have to find, that is j omega we have to find. This j omega tells this will occur when k equal to k max, the maximum value of k at which it will exhibit sustained oscillation. And after that, the system becomes unstable because the poles moves to the right hands, RHS. Till then, it was in the left hand side. So when k equal to k max, the system transfers from stable state to unstable state, that is in the marginally stable state when k equal to k max. That we can found that omega by using Routh criterion. By using Routh criterion, we can find. While using Routh criterion, how to find that omega? We have to make s power 1 row. Only one element will be there. We have to make it equal to 0. Then on making the s power 1 row equal to 0, we can find the value of k max. After finding k max, we have to substitute that k max in the s square row. Here, 2 elements will be there. It will be function of let us say ak. Therefore, you will get as square plus k equal to 0. You will get from that you can find s equal to k by a plus or minus j square root of k by a. You will get like that. We can find omega. S equal to what? S equal to j omega. Therefore, omega equal to square root of k by a. That value is omega. This point of intersection is square root of k by a. That is 8th rule. 9th rule. What 9th rule says? 9th rule is to find the value of k at a particular point on the root locus. Suppose I want to design a control system whose zeta must be 0.7. We know that suppose zeta equal to 0.7 means theta equal to cos inverse of 0.7. That is equal to 45.5 degree. So I have to draw a line at 45.5 degree. 45.5 degree line. This is called constant zeta line. Constant zeta line. That zeta equal to 0.7. Zeta equal to 0.7. Now it intersect at A with root locus. At this point, what is the value of K? If you know the value of K, if you substitute that value of K as controller gain, then the system will exhibit with zeta equal to 0.7. If you substitute that value of K here, the system will have a damping factor of 0.7. How to find a K at A? For that, what are the poles? Poles are P1, P2, and P3. So from A, draw lines to P1, P2, and P3. Measure the length. The length be AP1, AP2, AP3. These are the length measured from A to A is the desired location of pole. Divided by, suppose we are having 1, 0 here. Let it be Z1. So from A to Z1 also we have to draw a line. Let it be A Z1. Divide by A Z1. This is the value of K. This is the value of K. Product of, that is K equal to product of phasor lengths from A to open loop poles. Product of phasor lengths from A to open loop zeros. Here in this formula, S0 is taken as the point at which we want to locate the poles. So we can find the gain K at a desired location. If you put K equal to this value in a closed loop system, it will exhibit the desired zeta. Let us see one problem on root locus. Sketch the root locus of a feedback system whose open loop transfer function is given by S K upon S multiplied by S plus 2 multiplied by S plus 3. So what are the poles? It is a third order system. Therefore, the poles are 0, minus 2, minus 3. That is n equal to 3. Zeros nil. Therefore, m equal to 0. Therefore, number of branches, number of root locus branches, equal to 3. How many will end at infinity? All 3 will end at infinity because n minus m branches will end at infinity. M equals 0. Therefore, all 3 will end at infinity. Therefore, they will go to infinity at an angle phi a, that is equal to plus or minus 2q plus 1 multiplied by 180 divided by n minus m, that is 3. When q equal to 0, 1, 2. If you substitute 0, you will get 180 divided by 3 equal to 60 degree. Then 180 degree and 300 degree. 300 degree. So when q equal to 2, you will get 300 degree. This is the angle of asymptote at which the root locus branches go to infinity. The asymptotes are meeting at centroid sigma a, that is equal to sum of real parts of poles minus sum of real parts of zeros divided by n minus m. That is equal to sum of real parts of poles equal to what? Minus 2 minus 3 minus 0 divided by 3. That is minus 5 by 3. 5 by 3. 1.7. That is 1.7 minus 1.7. 67. That is 667 or 1 point simply says 1.7. In a graph sheet, we cannot mark 1.667. That's why let us take the single decimal place 1.7. They are meeting at 1.7. Now let us draw the root locus. For that, we have to take the S-plane. Take S-plane. Sigma j omega S-plane. So -1, -2, -3, -4, 0, j, 2j, -j, -2j. Here, what are the poles? The one pole at the origin, another pole at -2, another pole at -3. Any point between -2 and 0 are all the three poles are starting points of root locus. Between -2 and 0 is part of root locus because to its right odd number of poles and zeros. Therefore, both are starting point. Definitely, there will be a breakaway point. If you select any point between -2 and -3, it is not part of root locus because to its right even number of poles and zeros. If you select any point after -3, it is part of root locus because to its right odd number of poles and zeros up to -infinity, the root locus will have poles. So -1.7 is sigma A. So let us draw that asymptotes 1.7, 1.7. So that is 1.7 here. At an angle 60 degree, it goes to infinity. And this is also goes to infinity at -60 degree. That is 300 degree, 180 degree. So in 180 degree, this root locus and asymptotes one over the other. This is asymptote. This is asymptote. This is also asymptote. Asymptote. Now, this is sigma A. Sigma A. Sigma A is equal to -1.7. Now we have to find the breakaway point. For that, we have to find dk by ds equal to 0. What is k? K equal to -1 by g of s. That is equal to minus s multiplied by s plus 2 multiplied by s plus 3. That is equal to minus s square plus 5s plus 6. That is equal to minus s cube plus 5s square plus 6s. Therefore, dk by ds equal to 0. That is minus of 3s square plus 10s plus 6 equal to 0. The roots of this are minus 2.5 and minus 0.8. Minus 2.5 and minus 0.8 are the roots of this dk by ds equal to 0. So, two roots we are getting minus 2.5, but minus 2.5 is not on the root locus because between -2 and -3 no root locus. That's why this is not on the root locus, but this is on the root locus. Therefore, 0.8 is the breakaway point. 0.8 is the breakaway point. This is breakaway point. It come out like this. This is the point minus 0.8 is breakaway point. Breakaway point. So now we have to find the point at which it will go parallel to this asymptote. So it will turn and go parallel to this asymptote, but at what point it meets the j-omega axis, that we have to find by using the rule number 8. So we have to form the Routh array. Routh array. We have to form Routh array. For that, we have to write this is the characteristic polynomial. What is characteristic polynomial? 1 plus the characteristic polynomial is 1 plus g of s equal to 0. That is 1 plus k upon
s multiplied by s plus 2, s plus 3 equal to 0. If you simplify this, what you will get is s square cube plus 5s square plus 6s plus k equal to 0. If you simplify, take LCM and equate 0, you will get s cube plus 5s square plus 6s. This is the characteristic polynomial. This is the characteristic polynomial. For that, we have to use the root array. Therefore, s cube, s cube, s square, s cube, s square, we have to write 1, 5, 6, k. S power 1, then s power 1. That is 30 minus k divided by 5. S power 0 is k. How to find the k max? We have to equate s power 1 row equal to 0. If you equate s power 1 row equal to 0, k max equal to 30. You will get. So substitute that 30 here, you will get 5s square plus 30 equal to 0, or s square equal to minus 6, or s equal to plus or minus root 6. That is j root 6. J root 6, that is equal to minus 2.4. Minus 2.4. So it cuts the root locus at minus 2.4. This is minus 2j. Therefore, 2.4 will be here. 2.4 will be here. Here. Therefore, the root locus branch passed through that. We have to draw a line like this. It goes parallel to the asymptote. That's all. This goes to up to infinity. This also goes up to infinity. This is here. Suppose I want to find the value of k for zeta value of 0.7. Zeta equal to 0.7. I want to find the value of k. For that, I will draw a line. Draw a line that is constant zeta line. Constant zeta line. It's zeta equal to 0.7. The angle made with the negative real axis is 45.5 degree, because cos inverse of 0.7 equal to 45.5 degree. So this intersect the root locus at A. So we have to find the length from A to all poles. All poles. This is P1. This is P2. This is P3. All poles. No zeros. That's why only poles. The length equal to AP1. Length equal to AP1, AP2, AP3. If you know all these lengths, we can find the value of k. You can measure. Suppose this is equal to 1 centimeter. This is equal to 1 centimeter. Means you can measure the length by using your scale, and you can substitute. You can find the value of k. Or else you can analytically find AP1. What is AP1 equal to modulus of A minus P1. A minus P1. A minus P1. A minus P1 equal to what? A equal to, let us assume that let us assume A equal to minus 1 plus J. Just an assuming. Here we can find what is that A? 0.8. This is not 1, minus 0.8. So we can find 0.8 J1. A equal to in this graph, from graph A equal to 0.8 plus J1. So what is AP1 length? Analytically, we can find modulus of 0.8 plus j minus P1 is 0. 0. Therefore, modulus of 0.8 plus j, you can call the function polar to rectangle of 0.8 plus j. 0.8 plus j you can call, so that you can find the magnitude, or you can find this way, square root of 0.8 square plus 1 square. That way also you can find. So substitute, let it be AP1. AP2 equal to what? AP2 equal to modulus of 0.8 plus J1 minus, what is P2? P2 is at minus 1. Therefore, the magnitude equal to plus 1 minus 0.8 minus 0.8. This is minus A equal to minus 0.8. This is A equal to minus 0.8. Minus 0.8 because it is in the negative side. No? This coordinate is minus 0.8 plus J. Therefore, it is equal to 0.2 plus J. So, therefore, AP2 equal to, you can call polar coordinate of 0.2 minus 0.2 comma plus 0.2 comma 1. You can pass and you will get the value from the calci, or you can calculate this way, square root of 0.2 square plus 1 square. This way also you can find. AP3 equal to what? AP3 equal to minus 0.8 plus J minus of minus. Next pole is at 3 minus 3. Therefore, what you will get is 2.2 plus 2.2 plus J. Therefore, AP3, the length AP3 equal to, you can call polar coordinate of 2.2 comma 1, or you can calculate square root of 2.2 square plus 1 square. This way also you can find. So now we got no zeros. Therefore, denominator is 1. Therefore, K for 0.7 equal to AP1 multiplied by AP2 multiplied by AP3 divided by 1. This way we can find the value of K for zeta equal to 0.7. This way we can use the root locus to find the desired location of, find the value of K for desired location of poles. So the desired location of pole is at A, because at A it gives zeta equal to 0.7. That's all.